All right, section 8.1, we're going to look at the basic idea of what a confidence interval is. Okay, so to build our confidence interval, we're going to start with the point estimator, which is just the statistic that we're going to use to make an estimate of what our population parameter is. Okay, so the thing that we are finding is the point estimator. The actual numerical value is the point estimate. Okay, so here we have a random sample of 50 batteries, and we want to know the lifetime in hours of the battery. Okay, I want to estimate the population mean, mu. So my point estimator is the sample mean. Okay, and the point estimate is those 16.178 hours that I actually find if I were to find the average of these 50 batteries. So that 16.178 number, we know that the true population mean is probably not exactly that. And so what we're going to do is give a range of values, and that is what's called our confidence interval. So we know it's probably not exactly 16.178, might be a little bit smaller, might be a little bit larger. So we're going to give sort of that range, and we call that a confidence interval. Okay, a confidence interval, the definition is it gives an interval of plausible values for a parameter based on sample data. Okay, and important to note that plausible is not the same thing as possible. Okay, so plausible means we wouldn't be surprised by those values. They're likely to occur. It is not the same thing. It's not a list of all the possible values for a parameter. Okay, so what we do is we take the point estimate and we make that the middle of our interval. And then we calculate what's called a margin of error, and we subtract and add that margin of error to get our confidence level. So if here we had a point estimate of 0.65, that becomes the middle of my confidence interval. And then the margin of error is 0.037. And we'll talk later in the chapter about how to actually calculate that. But I'm going to take my point estimate, 0.65, I'm going to subtract 0.037, and I'm going to add 0.037. So my confidence interval here would be 0.613 to 0.687. That is my range of plausible values. Okay, so here is your definition for margin of error. All right, make sure we got that written down. Okay, and then much like we did with a lot of other things, we have to be able to interpret our confidence interval. All right, and so what we say is that we are blank percent confident, and our confidence interval comes with a confidence level. All right, so we are blank percent confident that the interval from, and then we give our two numbers, captures the true, and then we're going to say the true parameter value. All right, so make sure you're talking about the parameter that we are estimating and not the statistic that we actually calculated. So here we have an example. We have a poll before a presidential election, and they came up with a 95% confidence interval that the population proportion for people who favor candidate A is from 0.48 to 0.54. So somewhere between 48% and 54%. All right, so let's interpret that confidence level. Okay, we are 95% confident that the interval from 0.48 to 0.54 captures and then the proportion that or the parameter that we are estimating is the true proportion of all registered voters who favor candidate A. Okay, now part B, we want to know what is the point estimate that we use to create the interval and what is the margin of error. Okay, the point estimate is always in the middle, exact middle of your confidence interval. So if I want to find the midway point between the two of them, I can add them together and divide by 2, or I can, look at what the difference is and divide that in half. Sometimes it's easier to just do it in your head. Okay, so the point estimate, the halfway point between these two would be 0.51. Okay, so that's like the sample that we actually took. So from our actual poll, the sample proportion that we got was 0.51. And then we got a margin of error To get from 0.51 to 0.54, that's a distance of 0.03. So that is the number that we subtracted and added to get to our confidence interval. Okay, and then the last question is, based on this poll, we're going to claim that the majority of registered voters favor candidate A because we got 51% in our as our sample proportion. All right, use the confidence interval to evaluate this claim. And so we're going to say, because our confidence interval includes numbers that are lower than 0.5, right? Because it could have anything from 0.48 and above, then we do not have convincing evidence that more than 50% of registered voters favor candidate A, because there are numbers that are less than 50% in our interval, which means those numbers are plausible. All right, so when we construct a confidence interval, we are usually given a confidence level. A lot of times it's 95%, doesn't have to be though. Sometimes they'll go 99, sometimes 90. All right, and so we need to make sure we understand what that percentage actually means. All right, and so it is the overall success rate of the method that we used. So we are getting sample data, and we just studied sampling distribution. So we know that our sample data might not be exactly accurate, and that there are lots of different samples of that same size that are possible. So if they sampled, I don't know, 200 voters in that last poll, there are lots of different samples of 200 voters that we could create that would have different sample proportions, different p-hats. All right, and so the confidence level tells me that in 95% of those samples, I would get a confidence interval that would capture the true parameter value. Okay. And so when we interpret this, here's the sentence that we're going to use. If we were to select many random samples from a population and construct a 95% confidence interval using each sample, about 95% of the intervals would capture the true proportion of adults who favor candidate A, or whatever our parameter is. All right. So same thing, we did a 95% confidence interval, and we did in the last one, we did the interpretation for the confidence interval. This is our interpretation for the confidence level. All right, so you want to make sure that you understand the difference between the two, and that we are using the correct terms and the correct interpretation based on what the question is asking. All right, so to sort of give you a picture of what we were talking about with confidence level, right? So here's these black lines are a bunch of different samples that we took. All right, and so the black dots are the point estimates, and then the bars represent the confidence interval. All right, this green line is the true parameter value. So if you look at any of these black lines that intersect that green line, those confidence intervals captured the true parameter value. This red one did not, because it was, my point estimate was so low that even when I added my margin of error, I didn't get the true parameter value. All right, and so it's important that you note, all right, we can't say that we are 95% confident, or the probability that my confidence interval contains the true parameter value is 95%. That's not what it means. Okay, we can say I am 95% confident, but we can't say there's a 95% chance or a probability of 0.95. Okay, and then last thing we're going to look at is that margin of error. What can we do to increase or decrease that margin of error? All right, the margin of error gets smaller when the confidence level decreases. Okay, so if I think about it, if I want to be more confident, I'm going to increase the width of my confidence interval so that I can be more sure that I got that true number. All right, so like we have this Garfield comic here. The weatherman says that the high temperature will be between 40 below zero and 200 above. I would say we are 100% confident that he's got the true parameter value somewhere in there, because his margin of error is so large. The other thing that affects the margin of error is the sample size. Okay, so if we increase the sample size, it decreases the margin of error. All right, and we think about this like what we just talked about with sampling distributions. If I increase the sample size, I am decreasing the variability, so there is more of a chance that I'm going to be closer to that true parameter value. But what's important to note is that the margin of error just accounts for variability with our sample. It doesn't account for any sources of bias in how we got that sample. Okay, so as an example, we have a student who has a sample of 25 students, and she asked them to state their GPA and then created a confidence interval. So she's 90% confident that the interval from 3.14 to 3.52 captures the mean GPA. All right, what would happen to the length of the interval if the confidence level were increased to 99%? All right, to increase my confidence level, I'm going to have to increase my margin of error and make my confidence interval wider. How would a 90% confidence interval based on a sample size of 200 compare to the original? Well, the original sample was 25 students. So if I increase my sample size, I'm going to decrease the size of my interval. I'm going to be more sure because I have a larger sample. And then the last part is a potential source of bias that's not in her margin of error. So the margin of error only accounts for sampling variability. It doesn't account for any bias. So in this example, she asked students to say their GPA out loud. And so people might lie and kind of say that their GPA is higher than it really is because they're having to say it out loud to a person. All right, and that's all we got for 8.1.